Good morning, everyone. My name is K. Pranavi, and my roll number is 234G1A0488, and I am from ECE B section. So today my topic in the EM waves and transmission line is primary constants of transmission lines, which has a practical importance. Introduction. So before we get into the subject, we need to know what are the primary constants, and this primary constant comes in the transmission lines. Transmission lines which carry the EM wave signal from one place to another place. So in this transmission line we have primary constants and secondary constants, and now we are going to discuss about the primary constants. Overview. So let's see what is the definition of transmission lines. Transmission lines or conductors used to transfer electrical energy from one point to another, typically over long distances. They can be categorized into two main types: overhead lines and underground cables, depending on their installation. So let's see what is meant by transmission lines. So transmission lines are the conductors which actually transfer the electrical energy from one point to the another point. That is, it can be used over the long distances, and they are mainly categorized into two types, that is overhead and underground cables. So what is the importance of these transmission lines in the electrical engineering? Obviously in electronics engineering also it is used, but our main this subject is mainly used as an application for the electrical engineers. That is, transmission lines play a crucial role in power systems and electrical engineering as they enable the efficient transfer of electricity. We all know what is meant by power. So to have an efficient transfer, we need these transmission lines, which plays a very crucial role in to transfer the energy from one place to the another place. So they ensure stability, regulate voltage, and support grid interconnectivity to meet electricity demand. So, types of transmission lines. We all know that there are so many different types of transmission lines based on the application and or their design. So, some of the examples I can give are open wire lines, coaxial cables, and fiber optic lines. If you need to know further about this, you should inquire about the type of transmission lines. So there are many types, like 6 types. Here have included open wire, coaxial, and fiber. Uh, each type serves specific functions in various environments with unique characteristics and efficiencies. Like each type has its own characteristics, and each has a specific character that can perform in certain environment and situation. Primary constants. So now we are going to discuss what are the primary constants. That is, first one is resistance. Resistance in transmission lines represents the opposition to the flow of electric current, which causes power loss through heat generation. We all know what is meant by resistance. We have been studying this for the very long time, that we definitely know what is meant by resistance. So resistance, in a simple word, we can say it is the opposition of flow of current. So this mainly results in the power loss when the heat is generated. So the resistance is varied according to the material, length, area, because each type has its own resistance. When you compare copper and aluminium, copper has more resistance compared to the aluminium. Inductance. Inductance in transmission line results from the magnetic field created by a flow of current. It affects the voltage drop and the overall performance of the line, influencing exhibits bad behavior under the alternating current conditions. So, let's see what is meant by inductance. Do you all know what is meant by inductor, right? So, inductor has characteristics called inductance. In this inductance, transmission line, magnetic field is created when the current is flowed from one side to the another side. This affects the voltage drop and overall performance of the line, including its behavior under alternating current conditions. And there are still two types of primary constants, that is capacitance and conductance. Let's see what is meant by capacitance. You all know what is meant by capacitor, right? So this has the characteristic called capacitance, which actually stores the electric charge in it. So when current is flowing, this main components does to store the charge in it. The main functionality of the capacitor is its charges and discharges. It influences the line's voltage and current behavior, particularly in high-frequency application. Capacitance effects lead to phase shift between voltage and current, which are crucial for maintaining signal integrity in communication applications. So, what is meant by conductance? You all know resistance, right? So the reciprocal of resistance is called as conductance. So it accounts the dielectric losses which occur due to imperfect insulator between the conductors. So let's see what are some practical applications of these primary constants in the transmission lines. Power system analysis. Power system analysis involves studying the behavior of electrical networks, including transmission lines, to ensure reliable delivery and efficiency. Techniques such as load flow analysis, fault analysis, and stability studies help evaluate system performance under various operating conditions. Signal transmission. Transmission lines are critical for signal transmission in telecommunication networks. So in signal transmission, we need an efficiency. So this primary constants make ensure that we are sending the signal in an efficient way from one place to the other place. Network performance. Network performance in transmission context refers to the efficiency and reliability of data or power transfer across lines. Factors such as bandwidth, latency, and fault tolerance determine the overall effectiveness of the network, influence using user experience and efficiency. So let's see what are some important factors that we need in this primary constants. That is length of transmission line. The length of transmission line can affect the primary constants such as resistance, which on inductance, capacitance and conductance. Mainly resistance can be varied when the length is varied. Frequency of operation. Frequency of operation affects the behavior of transmission lines, influencing their reactance and inputs. High frequency signals can lead to increased losses due to skin effect and dielectric losses, especially designing systems for different operational frequencies. Load conditions. Load conditions refer to the amount and type of electrical load conducted into the transmission line. Variations in load can affect voltage levels, loss calculations, and stability. Understanding load variations is vital for maintaining system reliability and efficiency. In conclusion to this, we can conclude that the primary constants of transmission lines, that is resistance, inductance, capacitance, and conductance, play a vital role in their performance. Understanding these factors and their practical applications help improve the efficiency of power system and telecommunications. Thank you.